Let's now talk about volcanic eruptions. What is and is not a volcano? A volcano is any opening in Earth's crust through which magma has reached Earth's surface. Vents are openings at the surface of Earth through which volcanic material passes. Most volcanoes have a crater. That is, a roughly circular depression, usually located near the top of the volcano. Mountains and hills without vents are not volcanoes. Let me repeat this. A volcano is any opening in Earth's crust through which magma has reached Earth's surface. Vents are openings at the surface of Earth through which volcanic material passes. Most volcanoes have a crater. That is, a roughly circular depression usually located near the top of the volcano. Mountains and hills without vents are not volcanoes. In order to understand volcanism, we must understand how and why rocks melt and how melting rocks behave. Temperature increases with depth. The increase is more quickly in and under the ocean crust than in the much thicker continental crust. Pressure also increases dramatically with increasing depth. An increase in temperature can cause melting, just as a decrease in pressure can cause melting. The increasing pressure causes rocks to resist melting. Melting caused by a decrease in pressure can happen if the rock is being carried toward the surface by mantle convection. The presence of water or water vapor in rocks reduces its melting temperature. In subduction zones, water is carried down into the mantle by the wet oceanic crust. Here are some key terms for volcanic studies. Magma is molten rock below Earth's surface. Lava is molten rock reaching Earth's surface. A volcano is the surface vent for lava. Dissolved gases are mainly H2O, CO2, and SO2. These gases expand within magma as it nears the Earth's surface due to decreasing pressure. Gas pressure builds as crystallization takes place. The violence of an eruption is related to how easily gases escape from magma. Let me repeat this. Magma is molten rock below Earth's surface. Lava is molten rock reaching Earth's surface. A volcano is the surface vent for lava. Dissolved gases are mainly H2O, CO2, and SO2. These gases expand within magma as it nears the Earth's surface due to decreasing pressure. Gas pressure builds as crystallization takes place. The violence of an eruption is related to how easily gas escapes from magma. Nuée ardente, a deadly pyroclastic flow made of hot gases infused with ash and other debris, called a glowing cloud or glowing avalanche, move down the slopes of a volcano at speeds up to 200 kilometers per hour. They're produced by vertical explosions with downfall, lateral blast, and dome collapse. A lahar is volcanic mud flow, which is a mixture of volcanic debris and water. It moves downstream valleys and volcanic slopes, often with destructive results. A volcano is characterized as active if it has erupted in recorded history. Typical examples are Mount Etna in Italy and Mount Lamington. A volcano is characterized as dormant if it has not been seen to erupt in history, but shows evidence of recent activity, such as Mammoth Mountain in California and Crater Lake in Oregon. A volcano is characterized as extinct if there is no sign of recent or historic activity, such as Mount Kilimanjaro in East Africa. Volcanic eruptions can also be characterized as non-explosive eruptions or mild eruptions if we have low viscosity magma and low dissolved gas. Explosive eruptions or violent if we have high viscosity magma and high dissolved gas. Composition, temperature, and dissolved gases of a magma determine the explosiveness of a volcanic eruption. Let me repeat this. Composition, temperature, and dissolved gases of a magma determine the explosiveness of a volcanic eruption. These three factors actually control the viscosity of a given magma. By the way, viscosity is a measure of a material's resistance to flow. Viscosity increases with cooling. Volcanoes are generally grouped into three categories: shield volcanoes, composite volcanoes, and cinder cones, or scoria cones. Let's describe these categories. Shield volcanoes have mild eruptions, form gently sloping mountains, and shield volcanoes are some of the largest volcanoes. They are tens of kilometers wide and thousands of meters high. An example are the Hawaiian Islands, which have some of the largest volcanoes on Earth: Mauna Kea, Mauna Loa, Hualalai, and Kohala Maui, all of which are shield volcanoes. Composite volcanoes are stratovolcanoes. They're made up of alternating layers of ash, cinders, and lava. The lava is thicker than that of shield volcanoes. Gases are trapped in the magma, causing eruptions that alternate between flows and explosive activity that produces cinders and ash. Composite volcanoes are typically tall and have steep sides, such as Arenal in Costa Rica. Cinder cones, or scoria cones, are the most abundant types of volcanoes. Cinder cones are the smallest and most common volcanoes. Large amounts of gas are trapped in the magma, and violent eruptions of hot ash and lava occur. Cinder cones tend to be active for only a short time and then become dormant, such as in Puyehue, Mexico. Here is an illustration of the three types of volcanoes. We can see that shield volcanoes form gently sloping mountains. The Mauna Loa in Hawaii is a typical example of shield volcanoes. Composite volcanoes are typically tall and have steep sides. The Mount Fuji in Japan is an example of composite volcanoes. Cinder volcanoes produce large amounts of gas that are trapped in the magma, and violent eruptions of hot ash and lava occur. This has happened in Puyehue, Mexico, for example. As described earlier, some major causes of earthquakes are tectonic displacements. volcanic eruptions, and structure collapse, such as great explosions, landslides, avalanches, and more. Volcanic eruptions produce earthquakes. Earthquakes precede, accompany, and frequently follow volcanic eruptions. They are caused by sudden displacements of magma within or beneath the Earth's crust. Let me repeat this. Volcanic eruptions produce earthquakes. Earthquakes precede, accompany, and frequently follow volcanic eruptions. They are caused by sudden displacements of magma within or beneath the Earth's crust. There are two general categories of earthquakes that can occur at a volcano: volcano-tectonic earthquakes and long-period earthquakes. Hot, rapidly moving pyroclastic flows, that is, nuées ardentes, and lateral blasts may overwhelm people before they can run away. The tragedies of Mount Pelee in 1902 and Mount St. Helens in 1980 are examples. Release of poisonous gases may suffocate people. Such release occurred in 1984 at Lake Yos in Cameroon, when a sudden release of carbon dioxide from the volcano's crater lake caused the suffocation deaths of 1,700 people. Violent undersea or coastal eruptions can cause tsunamis. A major tsunami set off by Krakatoa in 1883 killed more than 36,000 coastal dwellers on the islands of Java and Sumatra in Indonesia. Eruptions may wreak such havoc on agricultural lands and livestock that people die from famine. Eruptions can also overwhelm cities and other sites of human activities. More people died in refugee camps than during the 1991 eruption of Mount Pinatubo in the Philippines. Let's describe some examples of volcanoes. The Nevado del Ruiz eruption occurred in 1995. Here is the picture. Nevado del Ruiz is an active composite volcano located about 129 in Bogota, Colombia. On November 13, 1985, a small eruption of Nevado del Ruiz produced an enormous lahar that buried and desolated the town of Armero, causing an estimated 23,000 deaths. This event later became known as the Armero tragedy, the deadliest lahar in recorded history. The eruption of Nevado del Ruiz produced swift-moving currents of hot gas and rock called pyroclastic flows. This eruption caused massive lahars, that is, mud and debris flows, which pose a threat to human life and the environment. Here is a picture of Mount Lamington in Papua New Guinea. Prior to Mount Lamington's devastating eruption in 1951, the forested peak had not been recognized as a volcano. After a long quiescent period, the composite volcano sprang suddenly to life in 1951, producing a powerful eruption during which devastating pyroclastic flows and surges swept down all sides of the volcano, killing nearly 3,000 people. The eruption concluded with the growth of a 560-meter-high lava dome in the summit crater. Now the mountain is quiet again, but is still considered an active volcano. Lamington's internal temperature has been dropping for many years, indicating that the volcano is not likely to erupt in the near future. Here is a photo of the 2008 Chaiten volcano eruption in Chile. As clouds of toxic ash and dust tower into the sky, they ionize the air, generating an explosive electrical storm. Colossal forks of lightning spark around the noxious plume as it spews from the volcano's crater, creating an image of raw, terrifying energy, as if the air itself were ablaze. The worst-case scenario is the collapse of the volcano accompanied by a pyroclastic flow, a devastating super-eruption of scorching dense gas and molten rock that would roll down the mountainside. This is what happened in 2008 in Chile. In this photo, the Chaiten volcano has triggered earth tremors and spewed ash 2 miles into the air. In this picture, a local resident cycles through the ash as it settles across the town. Here is a picture of the 2011 Puyehue volcano eruption in Chile. Flames reach up to the heavens as lightning flashes crisscross the sky. These extraordinary images show the full as Chilean volcano erupts for the first time in 50 years. Ash was thrown 6 miles up into the sky, and the South American government evacuation of thousands of residents. Winds fanned the ash toward neighboring Argentine resort city of San Carlos de Bariloche, in the center of Argentina, and its airport was closed as a result. Here is another amazing picture of the 2011 Puyehue volcanic eruption. Here is a picture of the Tambora volcano in Indonesia. The 1850 eruption of Mount Tambora in Indonesia was one of the most powerful eruptions in recorded history. The eruption resulted in a brief period of significant climate change that consistently led to various cases of extreme weather. Several climate forcings coincided and interacted in a systematic manner that has not been absorbed since. Despite other large eruptions that have occurred since the early Stone Age. Although the link between the post-eruption climate changes and the Tambora event have been established by various scientists, the understanding of the processes involved are incomplete. Here is a picture of the 1991 Mount Pinatubo eruption in the Philippines. A huge cloud of volcanic ash and gas rises above Mount Pinatubo in the Philippines on June 12, 1991. 3 days later, the volcano exploded in the second largest volcanic eruption on Earth in this century. Before the volcanic activities of 1991, its eruptive history was unknown to most people. It was covered with dense forest which supported a population of several thousand indigenous people. The effects of the eruption were felt worldwide. It ejected millions of tons of SO2 and other particles into the atmosphere, more than any eruption since Krakatoa in 1883. Global temperatures dropped by about 0.5 degrees Celsius, or 0.9 degrees Fahrenheit, in the years 1991 through 1993. And ozone depletion temporarily increased substantially. In summary, here are some of the most devastating volcanoes in recent times. Remember, there is a large selection of iMode education lectures, which can further enhance your knowledge of earthquakes, volcanoes, climate, and energy. Thank you for listening to this iMode education lecture.